Welcome to the online lecture series for Computer Organization and Architecture KCS 302 course. Myself Dr. Inderjeet Kaur, Associate Professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, we have discussed in the COA, in the first unit it was about differentiate among CO and CA, the need of CA, types of different addressing modes, the buses, bus arbitration. Then in the second unit we have started with the ALU operations, the different arithmetic operations, logical operations that can be performed on ALU. Then we have discussed about the types of CU, that was hardwired and microprogrammed control unit in the third unit, and recently we have covered the fourth unit, that was all about the memory, how CPU is connected to memory, what are the different types of memory, what are the different cache mappings, how CPU is connected to main memory, cache memory, what is the concept of virtual memory, and how page replacement algorithms they are being using the replacement algorithms. Then the fifth unit, it is about how input output devices they are being connected to CPU and how they are being responding. These are the different peripheral devices and they have different electromechanical and electrochemical concept, and CPU is an electronic device. So, how these both different devices they are connected together and how they are being giving the output, how they are being performing the operation. So, this unit, fifth unit, input output, it covers all about the different peripheral devices, different IO interface, DMA and all. So, starting from the IO organization, as we know that the IO organization of a computer, it depends upon the size of computer and the peripherals that are connected to it. The different peripheral means the different input output means like keyboard, monitor, mouse and webcam nowadays, and how they are being connected to CPU, how they are performing the operation and how they are responding to ALU or how they are responding to CPU. Then the input output subsystem of the computer, it provides an efficient mode of communication between the central system and the outside environment. So, they all are integral part of our home appliances also. We can see there are so many appliances we are working at our home and they are responding to us. In the manufacturing equipment we can say, or we can say in the transportation systems, or we can say banking or point of sale terminals, different IO devices they are connected to the computer and they are responding. What is the how the programming is being done and how they are being responding, that is the thing that we will be discussing. So, starting from the peripheral devices, that is the devices that are connected to an input output module, they provides a means of exchanging the data between external device and the computer. Why these devices are connected actually? We have connected the keyboard with our CPU, so that we can enter any kind of data, we can type any kind of message, means the data and programs the user can give the different external input. Similarly, mouse we can perform the drag and drop, then webcam we can give the image to our CPU. So, all the different devices they are being connected to the CPU, so that the different exchange of data as a information can be given to the CPU, so that it can be processed and again the output can be received. So, when I am saying ki these devices they are being attached to the computer, they are attached to the computer by a link to an IO module, and this link that is used to exchange the different things, that is control, or we can say the status or the data between the IO module and the external device. So, placing these different devices along with CPU, that does not mean ki they will start working on it unless and until they have the specified driver installed on our on the system. Nowadays the automatic drivers are coming. Earlier we were installing the printer driver when we are connecting the printer to specified parallel port. Nowadays a common USB port is coming and we are just using plug and play and that device starts responding. Earlier when we have to attach a webcam, then we have to install the driver for a particular driver for that. Nowadays plug and play facility is coming and we are just connecting and we are just giving that input or taking the output from that device. Means the communication between that input device or output device and CPU, it takes in a less time nowadays. That access time, it has been reduced. The most commonly input and output devices are monitor, keyboard, mouse, printer, magnetic tape, webcam, microphone, speakers, projectors, flash drive, etc. We are not going to the details of these input output devices. We will say ki how these devices they are connected to a interface and that interface is connected to CPU and how they can exchange the information, how they are being communicated. That is the basic point that we will discuss in this lecture. So, we can categorize the external devices into basically three categories. One is our human readable. Human readable means they are suitable for communicating with the computer user using video display terminals, or the example we can take as the printers. So, they are human readable in which the human can read the output what is coming. Then the second type, it is machine readable. Machine readable means that are suitable for communicating with the equipment, means magnetic disc or tape that we are using, or the sensors or the actuators, they are understood by our CPU. Then the third is communication. The third type of peripheral devices that is suitable for communicating with the remote devices such as a terminal, or we can say machine readable or another computer. So, these are the three categories of our external devices. Then the commonly used, we will quickly go through them. Mouse, that is we can say it is an input device that uses point and click technology to interact with the computer. How a mouse is being when it is being connected and it starts giving output, it finds out the exact location because it works on a point and click technology, the use of CG, computer graphics. Then the second, keyboard. The second, this is also a most commonly used input device to enter a lot of information, that is when the user wants to type anything, that is the most required thing, then we require this as a input device to be connected with our CPU. That means the user, it enters the different letters, different numbers or different symbols, the types of different types of keys are there in our keyboard to give the computer with the information or to instruct our CPU. Then the third type, that is the monitor. We can say it is a most commonly used output device that gives the facility to the user to interact with the computer more easily manner. So, it displays the signal that is being sent by the computer in a visual format. Actually, whatever processing it is happening in the form of signals. Because the system can understand the data in the form of zeros and ones. So, user cannot understand these zeros and ones. So, we require some sort of intermediate thing that gives us the visual display, so that we can understand and computer on his end, on its own end, computer can start its working. So, monitor, it is a common output device. Then the next is printer. Printer is again the common form of output device that is used to generate the hard copy of electronic data that is being stored into our computer. Suppose to make it more readable, we take the printouts. Then as I said, they both they have different logic. So, when two different devices they have to communicate, suppose I know English and French and the some second person to whom I am talking, he knows only German language. So, some sort of intermediator is required that knows both the language, that he can convert my spoken words in English to German and his spoken words German to back to English. So, that intermediate person, it is known as interface. So, this IO interface, it provides a method for transferring the information between our internal storage and the external IO devices connected. So, these the different peripherals that are being connected to a computer and the special communication links they for interfacing them with the CPU. So, these from this diagram we can see every connected device like keyboard or display terminal or printer or magnetic disk, they all are being connected to the processor using interface. This interface, keyboard and display devices, they are connected to interface, printer is connected to interface, then disk, then tape and so on. Whatever devices we want to communicate with the processor, they all are connected to a interface. Now, this interface, it is being connected to our control line, data line and address lines of the processor via buses. These are the buses. We have used 3 different buses in this case. We may have one common bus of the processor, then that bus will behave as a address line. First, it will be generating the address, then it will be controlling that and then it will be serving as the data line. So, these interfaces they will be connected to the processor using buses. So, this diagram it shows us the connection of IO buses to different IO devices. So, we can see that the purpose of communication link, it is to resolve the differences that are existing between central computer and every peripheral. So, this peripheral it cannot be directly communicated to processor, no. It cannot be connected directly to the processor, no. This magnetic disk it cannot be directly communicated to the processor. So, they have to be communicating using interface. This diagram shows us. Then the next question that comes to every person mind, that is what is the need of this IO interface? Why we need so much of interfaces whenever we are connecting so many devices to CPU? As I said earlier also, these peripheral they are already either electromechanical devices or they are either electromagnetic devices. So, whenever we have discussed the magnetic tape or magnetic disc working, we have said ki they are electromagnetic devices. When we have discussed the keyboard working, and then we have seen ki it is a electromechanical devices, and CPU we know that it is an electronic device. So, whenever we have to show the communication of CPU and memory transfer with these peripherals, so that means we are discussing about 2 different devices connection, either electromagnetic to electronic data transfer has to take place or from mechanical to electronic data has to take place or vice versa. So, that means the conversion of signal value is required. So, that conversion will require some intermediator, that intermediate is IO interface. Then secondly, the data transfer rate of peripherals is much slower because they are electromagnetic device or electromechanical device, then the transfer rate of CPU. So, again we require a synchronization mechanism, so that we can have a mechanism, speedy mechanism for both. Then third, the data codes and the formats in the peripheral they have different sets, but it is the word format for the CPU and memory that is the different. Then the fourth thing, the operating modes of peripherals they are different from each other, and it should be controlled whenever we are connecting any device to the CPU, so that not to disturb the operation of other peripherals when they are connected to CPU. So, to resolve all these 4 conflicts, we require some hardware component that is known as interface unit between the CPU and the peripheral, so that all the devices they can work properly. So, this was the need for our IO devices. Then next is IO command. What are the different IO commands? Actually, there are 4 kinds of IO commands. First, control. Control means to activate a peripheral and tell what it should do, that is the control command. Then we want to test. Test command. Test command, it tells the various status conditions that are associated with the IO module and its peripherals, that tells us the test command. Then third, read. Read means that it causes our input module to obtain an item of data from the peripheral and store it somewhere into its own register, means internal buffer. Then the fourth one, write. Write means it causes an IO module to perform the action to take an item of data from the data bus and store it somewhere to the peripheral. So, these are the 4 commands that are much required for when we are connecting any peripheral device to the CPU, that is control, test, read and write. Then what is the input and output system? There are basically 2 methods in which the processor it can address the IO devices. One is the IO mapped, input output mapped IO, and the second one is memory mapped IO. So, we will be starting from the IO mapped. IO mapped means the different set of IO devices that are assigned particular addresses. So, these addresses they are isolated from the address space that is assigned to the memory. As we know, when this is our main memory, so some portion it is reserved for OS and this is the portion of our main memory that is available for storing the data and programs. So, from this some portion is being reserved where we can generate any addresses for storing the data that is being used by IO. Then the execution of an input instruction. Suppose CPU has given one input instruction IN, then it will cause the character stored in that input register of that device to be transferred to a specific register in the CPU. Means suppose CPU has given the instruction in, this means some input has to be taken and that value will be stored into the register of CPU, just like it will be stored into the accumulator of the CPU. So, similar execution will take place. Suppose I take any output instruction, suppose I write out. So, this means out means the after out whatever is being written or whatever contents of an accumulator or any specified register, they will be displayed onto the output device. That output device may be either monitor or printer. Then there moving on to the address and data lines. The address and the data lines from the CPU, they can be shared between the memory and IO devices. Then there will be a separate control line that is required for executing the input and output instructions. Then let us see the arrangement of IO mapped, input output mapped IO. If I talk about the address space, so that address space it is further divided into the memory space and IO space. They have different, means this is the total address space that shows the memory address space and this is our IO address space. Separate memory space is there and separate IO space is there. And if I look the memory connections, so it comes out to be, this is my CPU and these are the different devices that are being connected up to n devices. As I discussed earlier also ki whatever device has to get connected with the CPU, it will be connected to that interface via that port. So, we have specified here ki device A is connected to a port 1 of IO port 1, then device B it is connected to IO port 2 suppose, and so on, and these different ports, they are connected to the CPU for performing the read and write operation. These are how they are being connected to our CPU. These lines shows, and then via then these CPU it is further connected to the memory via using address bus, and this CPU it is further connected to memory via data bus to perform the operations. So, this CPU for the user it looks ki these CPU it is connected to memory and different IO devices, but actually these devices they are connected to CPU using ports. So, whenever we discuss the working of our CO, we say ki this is our CPU, it is connected to memory, main memory, it is connected to IO devices, but these in this interconnection actually there comes a IO interface. Through different ports we are being connected actually. Then this is our processor, this is the memory that is being connected the address bus and the data bus, and this is our control bus. Three different buses we have used. Data bus is bidirectional to perform the read and corresponding write operations. Then this processor it is being connected to different IO devices just like keyboard and graphics display in this case. So, separate control lines they are being specified. Here the input device control lines are there, and this is the output device control lines are there, and the data and address bus that are common, that are connected to memory, and they are connected to our input and input and output devices. This is the address bus and this shows us the data bus. This is address, this is data, this is data and this is address, and the special control lines for every device it is being shown. Moving on to the advantages, that it tells there is a separation between the memory address space and that of IO device. We can differentiate easily. So, it is the advantage, but disadvantage, there is a need to have a special input or output instruction in the processor instruction set, and it increases our complexity also. Then the second type, that is the memory mapped IO. Memory mapped IO means suppose to deal with the different input or output registers, suppose if they are regular memory locations. For example, suppose we have written the read device 6, it is equivalent to perform the input operation from the input register that is connected at this address. Similarly, we may write any command for write operation also. Means we are directly accessing the memory. The advantage for using this memory mapped is there is no need to introduce the special IO instructions actually, and the disadvantage comes we need to reserve a certain part of the memory in the address space whenever we require a address space for addressing the IO devices. This diagram it shows this is our processor, this is the three buses that I have discussed, address bus, data bus and control bus. So, we can see the control bus, the control signals are common for our input device and for our output device and for our memory. So, there is advantage also ki no need of introducing the separate IO instructions for every device that it was in case of IO mapped, but it increases our complexity and we need to reserve a space for certain amount of memory address space. So, as I was talking, this is our total address space. So, we need to specify the IO address space separately and this is our memory address space specifically. And if I say ki in case of memory mapped, this is our CPU that shows the connection being connected to memory and different devices through port, but there is a common control bus signal performing read and write operation between memory and IO. But in our previous diagram we can see that it was different, the control signals they were different, only the data and address bus was common, the control signals for every device they were different. But in case of this we may see that there is a common read and write control bus signal that is connected to memory and IO devices with the CPU. Then let us discuss the communication of processor buses with the memory and IO. So, to communicate with IO, the processor it must communicate with the memory unit. Like the IO bus, the memory bus it also contains the data, address and read write control lines. There are three ways that the computer bus can be used to communicate with the memory and IO. The first method that tells ki use the two separate buses, one for the memory and another for IO. Then the second method says use one common bus for both memory and for IO, but the control lines for communicating with the memory and control lines for communicating with IO they should be different. And the third method it says ki use everything common, means use one common bus for memory and IO and there should be the common control lines. So, we will discuss the first method that says the computer it is independent set of data, that means it has the address and control buses for accessing the memory and IO they are different. So, it is done that gives us a separate IOP. The purpose of this input output processor it is to give us the independent pathway for the transfer of information between the external device and the memory. So, this diagram it shows the two different buses for memory and IO. Here we can say this is our memory bus, this memory bus will be having the data bus, address bus and control bus, and this IO buses they have again the different three buses. This the second bus we can say there is a common bus, but the separate control lines, there is the common data and address bus used for memory and IO, but the control lines from the CPU they are different. Here we can see everything is common, there this data and address bus they are common for memory and IO, and the control bus that is also again the common. So, if we discuss the memory mapped versus IO mapped, we may differentiate among them based on the addressing, based on their address size, based on the different cycles, based on their register communication, based on their space involved, based on their input output or memory accessment, based on the different control signals and different arithmetic and logical operations, we may differentiate among the memory mapped and IO mapped. So, this was all about IO interface, the need of IO interface actually, and the two types, that is the IO mapped and the memory mapped. Thank you.